guess in the interest of honesty, this is really a talk about TikZ and not so much about PGF. So in a few minutes, I'll introduce I'll have a few more comments about PGF, and then I won't say anything more about it. So what is it that we'd like to say about these two packages? Well, first of all, if you look at if you know nothing about graphics in the tech world, as I didn't know too much about myself, and you go look at the FAQ, you'll find that there's sort of a lot of choices. And so that's why I refer to this as a jungle. And so how do you choose one? And to make a choice is kind of a big investment. Here's 250-page manual, go. And so that's part of our motivation for being here. So like I said, TikZ and PGF, two separate packages, but they're integrated in a certain sense. TikZ provides a convenient way to get hooks into PGF, which I think takes care of all of the low-level details of the actual drawing. As you'll see in a few minutes, some of the syntax will now be familiar to you. Some of the TikZ syntax. A lot of it will look a little bit like MetaPost. For those of you that might have experience with PS tricks, you'll see some similarities to that as well. TikZ allows a variety of input formats, plain text and LaTeX among them. I'm only going to talk about one of these, LaTeX. It also provides multiple outputs, formats. I'm going to I'm only going to talk about one output format, PDF. And everything that you're seeing here today has been done with Beamer. Every graphic you see has been produced with TikZ. So that will be proof that these integrate nicely. Well, I already told you there's lots of documentation. I found some of it hard to navigate, and so hopefully this Reader's Digest version will perhaps be of some assistance if you're interested in pursuing this. Okay, so you crack open the 250-page manual, and you see lots of stuff, and these words jump out at you. And fortunately, a lot of these words are familiar, so you feel better about it already. So there's transformations, great. You can scale very easily. In fact, you don't even need to know how to double 72, because you can just say scale equals 2. And so a lot of it is very straightforward. So being a Reader's Digest version, I'm not going to, I can't hope to be comprehensive here, but I will show you what I think are some of the more basic things that a TikZ user would need to know. Okay, so the first thing that you need to know is, well, what do I have to add beyond the usual stuff that goes into my document? And at the very minimum, you would need something like this: use package TikZ. Depending on what kind of TikZ picture you're drawing, you might need a few other packages. So for example, PGF provides, TikZ and PGF provide a wide variety of different types of arrowheads. And for some reason, if you want to use an arrowhead that's not the default, then you have to dip into the library to gain access to that. There's also something called a snake, and if you want to use a snake, well, you've got to dip into the library to get access to those snakes. And you can guess what a snake is. It's some sort of a wiggly line. Now, the actual picture that you're going to draw is then embedded somewhere within your document, wherever you want it to appear, perhaps in figure, perhaps not. And it's simply a TikZ picture environment. Begin TikZ picture, and then whatever TikZ commands you need to draw the diagram that you're interested in, followed by the end of that environment. Okay, that seems simple enough. How do you process this file? For me, it's nothing different. It's what I always use now, PDF LaTeX. So I've got my text file that I just showed you an example of, a LaTeX file. Somewhere in here I've got one or more TikZ environments, and I process it with PDF LaTeX, and out pops my output file. If you were so inclined, and you wanted to use TikZ to produce sort of standalone graphics, you could do that. Then you just manufacture one file that would have only one TikZ environment. You'd process, you'd get one page of output, which of course would typically have lots of blank space above and below that. But then you could use something like PDF crop to trim away that blank space. I haven't needed to use this because I like the idea of just including all of the graphics that I'm going to need right in the file that I'm working on. So it's a little bit a different approach than what you might be used to from, say, using the graphic X package, where all of your graphics are external. Okay, so here's something that's not too surprising. Cartesian coordinates, go over A, go up B. What I haven't said here, and I have to thank Troy for the great introduction to graphics in general, because now I don't need to say much about that. But you might be wondering, from what you just heard a few minutes ago, well, what does that mean to go over A units? And it turns out you're not going over one big point. By default, you're talking about a unit of 1 centimeter. If you don't like that, you can change it. So there's a syntax, of course. In this case, there's some syntax to specify this point. The syntax looks a little bit peculiar. In fact, I think you have to read to page 92 before you stumble onto this. And it's not strictly speaking needed, but I found this syntax quite helpful. And what it provides me is a way to attach a name to this point. And the reason it's not needed is you can draw lots of diagrams without naming any of your points. But if you want named points, you pretty much need this type of syntax. So here it is, \path, ordered pairs, just as in the usual Cartesian coordinates, the keyword coordinate, and then in parentheses, and then your favorite point name, P, say. Okay, so now having known that, forget that, and let's just use 4 unnamed points. So think again of the Cartesian coordinates. The origin, which you can't see, is right here. And I'm just going to draw, starting from this point here, so go over 1 unit on the x-axis, 1, 0, up to 0, 1, then down to -1, 0, then down to 0, -1, and then form a closed path from that. And just as you saw minutes ago, the -- syntax causes these straight line segments to appear. So pretty simple. Incidentally, in this previous picture, you might wonder, you're drawing somewhere here on the plane, you draw this picture, and well, what do you get as the final result? And the rough answer is TikZ will draw the picture on that plane and then trim it down to an appropriate bounding box. So you can't always necessarily just look at the final picture and say where the origin is. And usually it's not an issue. So I'll be pointing out from at various times here, I'll be pointing out where the origin is just so you can get your bearings. So like I said, the origin's here. Who cares? If you make mistakes while you're doing this, it might be handy to have a grid. So to cause a grid to appear, here's what I did. Draw, same command, some options, never mind the options for the moment. And I'm using a new keyword here, grid. And for a grid, it's a little bit like a rectangular region. You give essentially the 2 opposing corners, either these 2 or these 2. In this case, -1, -1. So again, the origin is here. So -1, -1 is down here. 1, 1 is up here. And I get the grid. Now, the options that I told you to ignore, in this case, give me the granularity of the grid. So every 1/4 centimeter, 1/4, 1/2, 3/4, 1, there's 1 centimeter, and so on. The color gives, of course, the color of the grid, and I'm using the color package. I'm saying but TikZ is using the color package. So this is a 30% shading of blue. there are lots of things that you can do along the way as you draw a path. Well, what kinds of things? These are just 4 simple examples. You could fill the path in addition to drawing it. You can change the pen color as you're along the way. You can change the pen width, as you can, if you remember what we saw a moment ago. Here we have the default pen width. Here I've changed it so it looks like about twice as wide maybe. And you can adjust the transparency, which is kind of a nice thing. So if you look carefully here, you can see that even though I've filled this with some sort of blue in here, the grid is still visible. And that's potentially a nice thing, in my opinion. How did this happen? Well, you can maybe guess that what I had to do is to provide more options to the original draw command. So here are the new options that appeared. And they pretty much match the actions that I was describing. I want to fill. I want the filled color to be 30% amount of blue. Draw equals red is the color of the drawing pen that I'm changing, so the border turned out to be red. I want the line width, the pen width, to be 2 points. And I want the amount of opaqueness to be about 50%. Not about 50%, 50%. And then there it is, just as before. Okay, so for those of you that don't like Cartesian coordinates, you can use polar coordinates, which is kind of a handy thing from time to time. And the syntax is this. And when I learned polar coordinates, and I always had to sort of recite this back in my mind, it was r theta. Well, here it's sort of the other way around. So the angle comes first, and the distance comes second. The syntax requires a colon. And here's something a little bit unusual. What I just showed you a moment ago was essentially dimensionless, but behind the scenes, remember that we're using default centimeter unit vector. Here, in red, I'm indicating that a dimension, some dimensional unit must appear. So points, centimeters, inches, whatever you think is appropriate. Okay. So if you think of this as the origin, and if you think of a circle, then you can take 5 equally spaced points, and polar coordinates would be the ideal choice to specify these 5 vertices of this pentagon. And now you have to think back to the slide I told you to ignore. So here I'm naming points, P0 through P4, so those would be the 5 points around the pentagon, in addition to the origin at 0, 0. And just for variety, I've mixed this a little bit. So I've got a Cartesian coordinate here at the origin, 0, 0. The remaining 5 points, I'm using the polar coordinate syntax. So here my angles are walking around that circle counterclockwise, 0, and then in multiples of 72. And again, what's nice here is for the arithmetically challenged, you don't need to multiply yourself by 72, but it uses the calc package. So there's, for those of you that know the calc package, I was expecting more than it provides, but it does provide infix arithmetic. So there's a limited amount of arithmetic that you can specify. So there it is. I've got now these 5 points on the pentagon together with the origin. And the rest, I guess, isn't going to be too surprising. So to get the pentagon edges, start at, well, P0 and walk your way around. And then this is a slightly different syntax just to sort of show off a little bit. Notice that this is one draw with connection between each successive pair of points. Here's a draw that goes from the origin to P0. And then move the pen back to the origin, but don't draw. So it's like, do this, take a breath, do this, take a breath, draw this, draw this, draw this. So that's kind of nice. Again, the named points, I think, is contributing a little bit to the readability of what comes next. Okay, what else? So I've shown you line segments. So if you can imagine your picture is composed of line segments, you can go to sleep now. You're done. If you need more, then pay attention. So what if you need a rectangle? Okay, well, that's not far off the grid that I already talked about. So rectangle is the keyword. Just like grid, you give a pair of opposing, essentially bounding points, bounding box points. And this is just one example. You could use the other pair of points if that's more convenient. Okay, so let's have an example of this. Okay, this matches the same kind of syntax I was showing you before. So think of this as one giant command. It's the fact that it's spread over 3 lines is not important. The fact that it ends with a semicolon is important. So each of these commands must ultimately end with a semicolon. So look, it says, draw this, take a breath, then do this, take a breath, then do this. Each drawing action, there's a notion of a current point. So each drawing action leaves the current point somewhere. So let's see if we can figure this out. Start from the origin, which by the way is here. Draw a rectangle by going up to the opposing point at 1, 1. So that gives me a unit square. 1 centimeter, again by default. Now what happens next? It says draw a rectangle from 3, 2, but fine, where was the other point? Well, that's where it was left off, which is here. So from this point, draw a rectangle from 3, 2, which takes me to here, and from that point, draw the final rectangle going up to 4, 3. And even though I wouldn't probably specify it in this way, just to sort of make sure we understand what's going on, does this make sense? Start at the origin, which is here, go up to 1, 1, and then look, rectangle 2, 0, which takes me down to here. So there's the pair of bounding box points. And then 3, 1, which takes me up to here. There are more direct ways to accomplish that, but I'm just sort of illustrating this notion of updating the current point. Okay, so if line segments and rectangles and grids, if that's what floats your boat, then we're done. If you want more, then you need a few more keywords. So, circles. Let's see, what were you saying? You didn't like the diameter, but you like to think of circles in terms of radius? Good. We got a radius. Just as before, you've got to have a dimension. So AB takes me to the center, and then, so again, it's once you've seen grid and rectangle, this is kind of familiar now. Incidentally, if you don't like this syntax for specifying that point, of course you would use polar coordinates. Okay, so maybe I'll just look at one of these. And again, if you're just trying to figure this out, for all of these commands, you need to know what happens to the current point as a result of this command. So you can probably guess based on this example what happens. Anyone willing to go out on a limb and say? Doesn't move. Right? So we start at the origin, we draw a circle, stay at the origin, draw another circle, stay at the origin, and draw this final circle. And there's nothing terribly surprising here, so I think in the interest of time, I'll just skip it. Okay. Ellipse. Well, ellipse, here it is, AB, which is our center point. And then the syntax requires this keyword and, which gives us an opportunity to provide a pair of radii. Each radius requires a dimension, which by this point is no surprise. So here's an example, a couple of examples actually. Maybe we should look at this one. Draw with some options. Notice that in all 3 cases, I'm starting at the origin. I'm drawing an ellipse. It's being filled with various colors. This is, I guess if you want to look for an analogy, this would be like putting felt on a felt board. So notice that if you were to slow this down and watch what happens in detail, it's going to fill the entire outer ellipse with blue, which would fill everything. And then on top of that, I'm going to fill this smaller ellipse with white, which removes that blue that was there just a moment ago. And then finally, I'll put the smallest red ellipse at the center. Okay, what about just a portion of a circle? Syntax is as follows. You first need to specify a starting point, which can be specified in your favorite way, Cartesian coordinates, polar coordinates. There's actually something else that I have not mentioned and won't be mentioning, but there are other ways to do arithmetic on points. So you can, this said I wasn't mentioning, but here I am talking about it. You can basically start at a point and do some arithmetic and move around and end up somewhere else. But somehow you've got to get to a starting point, which I'm calling P here. Once you're there, then it's pretty straightforward. You give a pair of angles, which specifies the sweep of that angle, and the radius, which, you're not surprised, requires dimension. So if you want a simple example of that, well, here are a few examples. And again, in the interest of time, I think maybe I'll just talk about one of these. This one I kind of like. And I don't know what this is called. It's a piece of the flattened donut. Now let's see here. So here's a draw with some options. And notice what this draw is composed of. So there's a straight line segment, followed by an arc, followed by a straight line segment, followed by an arc, and then make a closed path out of the whole thing. So the straight line segment, well, you can sort of, even without figuring out the detail here, you can figure out, well, it must be that piece and this piece. Let's see here. If you care about honesty, does this make any sense? We start at, here's the origin. That will maybe help get our bearings. So we start at an angle of 0, go out 0.4 centimeters, which must take me to here. And then I draw a straight line segment out to a circle of 1 centimeter. So that takes me from here to here. Then from there I take a path along an arc, sweeping out an angle starting at 0, ending at 60 along a circle of radius 1 centimeter, which takes me counterclockwise up to here. Then the straight line segment back to the smaller circle, and then an arc. In this case, notice that I can specify the pair of angles going clockwise, starting from 60, sweeping back to 0. So that's kind of nice.
Question. Would you go back a slide? Is your the point that you labeled P, is that not the origin? Because your arcs are I'm not familiar enough with the mathematics here, but it seems to me that your P is your starting point from which you measure the arc angles.
Well, I think the answer, I'm not sure I understand your question, but I think the answer is yes. I think you're right.
Good. So P is the center of the circle rather than a point.
No, P is not the center of the circle. Here is the center of the circle. P is the initial point of the arc.
I thought that was the part where the origin is.
Yeah, well, you need to specify the 3 coordinates give the initial point of the arc. We don't know where the center is.
Yeah, I think you need to specify the
No,
center of the circle.
Well,
That's my question.
But
That's what art tells you.
we're given the radius.
From where?
From the center.
From the center. How do I specify the center of the circle from which I'm drawing?
Yeah, you have to use the angle alpha, and the angle is always from the horizontal.
Good. When I figure it out, I'll
Okay, so, all right, so I'm not going to, these are just for show. Okay, so then we also have Bézier curves, and by the way, in the interest of honesty, the circles that I've shown you, of course, you can guess are not circles, but are approximation to the circles via Bézier curves. This is, in my estimation, and I don't know Metapost well at all, but I think this is not as well developed. The aspect of Bézier curve is not as well developed in this package as Metapost. So here's the primary way to specify a Bézier curve. You have the 2 endpoints and then the 2 control points. So this is a standard way that Bézier curves are typically specified, but we don't have the nice sort of keywords that sort of hide these control points. Right? I think we had this example before the break of keyword of going off to the right, which gives me a horizontal tangent. There is, as I'll show you in a minute, there is something close to that. But in case you haven't seen some nice Bézier curves here are just a few samples of the kinds of things that you can accomplish. Since this isn't a drawing program that you use with mouse and get immediate feedback, it's sometimes, well, for me, it's challenging to know where do you set this control point to get the kind of curve that you have in the back of your mind. That's, I think, the hardest point. What helps, I think, is to realize that you usually have some notion of how steep you want that curve to be at the two endpoints. And there's an alternate syntax that allows you to specify that. And here's the alternate syntax. So the syntax basically says, starting P, ending at Q, and the two control points I'm going to specify with polar coordinates. So again, the dimensions are there. So this gives you a nice way to specify the type of tangency that you want here. Now you're still on your own just to figure out how far that control point should be along that segment. And in my experience, it takes a little bit of trial and error to get what I want. Maybe you're better at that, but at least being able to specify the angles is quite handy.
Since there's an AND operator in there, can we put in more than two
No.
control points?
No,
Just two.
just two. You could put one, and if you use one, then that one control point is used to serve double duty. And now I'm going to pass it off. I'm going to pass the baton, so to speak, to Andrew.
Okay. So we've actually, we've already seen one way that we can name a point and essentially remember its location and use coordinate to do that. We can do, coordinate is essentially kind of the stripped down node. Well, okay, what's a node? So here we're taking a path and we're going to specify a node. We're just going to be using polar coordinates here, so this is just the origin. And so you specify a node using the node command instead of a coordinate. But now we can do a lot of other things with it. In this case, I'm going to tell it that I actually want that node to be drawn on the screen, on whatever my output media is, and it can have a shape. If I leave the shape off, then it's going to put a rectangular box there. It can have a circle, so it's circular. It can have, there are others for states in a finite state machine, and so on. So there's several different types of shapes that we can use. There's a library that gives us access to more. And then draw just tells me, well, I actually want this shape to appear. Then I can give it a name. So that's the same syntax as we use with for the coordinates. So here I'm going to call this one V naught. Associated with the node, we can also give it some text that we want to appear. And we can embed whatever text that we want there. And this is actually the way that we get text to appear in our drawings. So if you want to embed a label of some kind, use a node to do it. If you don't want a circle around it or a box, then you leave the draw off, and it doesn't show up. So this gives us a way to essentially put that V naught in there. Okay, here's the rest of the detail for that last picture. Now, when you're giving, we'll see a few ways that we can do this, but sometimes you don't want to have to write down, okay, every single node from here on out I want to draw, I want it to be a circle, I want it to be this. We want to be able to say, okay, just for all of these nodes, we want it to have these options. So here we're just going to say there's TikZ style, and this gives us, just like with Beamer, there's Beamer style, where you can customize the various style options. Here we can do the same thing in TikZ, and we just say, okay, for every node, I want them to all be drawn, and I want them to all be circles. And then we just specify the various nodes of our graph, and using the familiar polar coordinate syntax that we saw before.
Can you do this outside the TikZ picture, so it will go for all the TikZ picture after this?
Yes. Yeah, the TikZ style, I believe, can be embedded outside of environment, so that it takes effect for all of them. I believe that to be the case, if I remember it correctly. If it behaves like the Beamer styles, which I think it does, you can. So then I just tell it that I want it to draw to essentially connect these nodes here. But notice what it did in this particular case. It realized that there's a circle around there, so it didn't actually go to that coordinate. It gave me some standoff distance, and it essentially connected to those, it just connected the outside of those two. So we'll do that automatically. I can choose that anchor point by hand, and we'll see how to do that. But if I leave it off and I just say connect to this node, it's going to pick whatever it considers to be the best anchor point, and I can change that if I want. Okay, so that's how we can do that. One of the other things that is included with TikZ is actually a standalone library that if you wanted to, a standalone package, you can include it without including all of TikZ, and that is the ability to do loops. So from the documentation, Tiltanto said that he kept forgetting essentially the syntax for all the different, for some of the others, so he made his own. So I have to admit, I kind of like that attitude. To be able to just like, oh, well, you know, I want to make my own. So that I always know how to do it. So anyway, so he created his own iteration, and here we'll use it to construct this bipartite graph. So the way that we use those iterators is it's for each, and so you do \for each. Then what you do is you give it whatever variable you want to be, and essentially what it's doing here is it's doing it's making its own, doing a new command for that area. So I'm going to use \I as name my iterator. And then I say for all the values in this particular range, and we denote it with curly braces. And if you wanted to, you could actually explicitly put whatever objects you wanted to be in there. They can be names, they can be text, they can be points, they can be other coordinates. And so you can explicitly just give out the list, or you can establish a pattern. In this case, I don't really establish a pattern, so it's just going to be adding 1 each time, and put the 3 dots there. So this is just going to, for all the values 1, 2, 3, and 4. So you just give the starting point and the ending point. And then inside of these braces, we put the code that we want to be repeated. And so here what I'm doing is I'm just establishing a new coordinate. So this isn't a node, I'm just remembering a name. And where do I want it to be at? Well, I want it to have the x value I, the y value 0, and it's going to be a coordinate named x \I. Once I've established that point, so I can refer to it again, I'm going to put a circle there of size 1 point. Do the same thing for my points, for my nodes really, in sense of the graph on top, and then I've got a nested loop here to connect the two. So you can nest them if you want, and so on. So this is one of the ways that you can use a loop.
Programming in tech.
Yeah, programming. Yeah, it's a programming in tech. So, and again, yeah, you can combine this with the package if then, and then you've got a lot of power. So here to talk about 2 things kind of at once. See a little more of for each, but also you have the capability in TikZ to do transformations. So often, you've got maybe a path that you've already defined as a macro, and you're going to be putting it in lots of places, but you want to rotate it around, scale it, change it in some way. Well, you can do that with transformations. One of the basic transformations is rotations. You just take it and essentially twist it in the direction that you want. So here what we're going to do is we're just for each, alpha is going to be the angle, for all the angles within this range. And notice here I'm establishing a different pattern. I'm starting at 0, then I'm going to 60. I put the 3 dots there, so now I'm incrementing by 60 each time. And then I tell it here I want to draw, and then I pass this draw command the option rotate, and I tell it how far I want it to rotate. I want it to rotate by alpha. So it's just going to take this path, which is essentially this one here, and then I'm going to tell it I want it to rotate it by 60, then keep going. Actually, take that back. Let's see, it'd be this one. Keep to rotate. So yeah.
Just being naughty, but what happens if you want the letter alpha?
If I wanted, yeah. So if I wanted to, so that's a really good question. So here, what I've done is I've just destroyed my alpha. So if I wanted to, if I wanted to actually use that within that iterator, I need to choose something different. So for the scope of these braces, I don't have access to \alpha as normal. So we do have to be careful of namespace collision, but.
You have no problem with data types in the previous one. You form the name of the point by iterating back
Right.
right.
Yeah. So back here, so we combine them to create a unique name that way. Okay. You can also do, I don't illustrate it here, but there are other, you can also do a rotation around a point, and do a rotation about an arbitrary point, and so on. Here's another example of rotation. Really, it's like the last one, but here I wanted to show a little bit different syntax, a little strange syntax, but sometimes instead of doing, say, a nested loop, you may want to be able to essentially iterate over a pair or maybe a triple or something more at the same time. And this iterator for each allows you to do that. So here I'm going to specify a pair of values, alpha and c, and we separate them by a regular slash. And then for each of the values and 0, again, slash red, and so on. So the way this is going to iterate, alpha is going to take on the value 0, c is going to take on the value red, and then next time through, alpha is 120, and then slash c is equal to green. So it allows you to essentially step along time. This I've actually found to be fairly useful. That's about all I'm going to say about that one. Okay. Very good. Another thing that you can do with TikZ is do plots, and actually it uses GNU plot to do this. So there's a little bit of setup that you have to do to get this to work. You have to have GNU plot on your system. Your tech has to be able to essentially, I think it's shell escape. There's a command that you have to, just so it can invoke outside commands. But when that's all set up, you can essentially tell it, I want to draw, give it some options here, smooth, give it domain, which tells it the range that I want it to plot over, and in this case, tell it to be red. Tell it that I want to make a plot, and then I give it a function. Then whatever is in here is the function that it's going to plot. There are also ways to essentially embed raw GNU plot commands into here, and so on, but we won't be showing that detail. There are a lot of different plot types. You can plot coordinates where you just give a sequence of points, any of the types of points we've talked about, polar coordinates, Cartesian coordinates, named points, whatever you want to put in there. You can also plot from a file where this is just XY tabular data. It's actually as GNU plot produces, or you can have GNU plot produce it each time. A lot of options for your plot types. You can put marks at each of the given points. You can make them smooth so that there's a nice smooth Bézier curve between them. You can make it a closed curve. You can do horizontal or vertical bar diagrams by using X cone or Y cone, and you can set the length of the pin. And I'm running out of time, so try to get through this really fast. Here's an example of another a little more complicated plot to illustrate how income was growing back in 1947 to 79. You can contrast it with how it's going today, and it doesn't look nearly as balanced. But anyway, the main thing here is this is just using Y cone to create this bar chart, and have some sample code here. One of the main things, there are a few things going on here, and one of which is I wanted to write my coordinates here in terms of the data. So I was thinking of this as my first bar, which being a computer scientist, I would of course think of bar 0. And so bar 0 has a percentage value of 116. So I want it to be 116. Well, how is that going to scale on my and there are other ways that you can make these transformations. So you have a lot of control over that. And then that's really somewhere. Another very useful tool is being able to clip. So sometimes when we draw a particular path or fill a particular path, we want it to be restricted to being within another region. So these are the commands just for creating this this blue shaded region, the intersection of these two sets of this Venn diagram. And so here I'm saying, okay, I want to clip to this circle, this first circle here. So now, once I've established this clip, anything that I draw from there on out is going to have to be inside that. Then I say I also want to clip to this other one, so now I'm putting dual restrictions here. Anything that I draw has to be within both of them. And then I tell it, well, okay, just fill this entire rectangle with blue, but because of the clipping restrictions, it's only going to show up in that one place. So this is a convenient way of being able to draw some complex diagrams. Example of that is the yin-yang symbol. And so the way to do this is essentially we're going to draw the circle. Then I'm going to fill in this black rectangle here, but I want to clip it so that it stays within the circle. Then I put a black circle up top, then I put a white circle down below. and my 2 other circles there. So clipping allows a nice way to be able to draw that. Notice that I used the scope region, and for an amount of time, so I'll cover this fairly quickly. The scope can really be used in kind of 2 ways. You can use it to restrict what clip applies to. Without scope, it wouldn't have been such a bad deal in that last one because everything that I'm drawing is within that circle. But sometimes I want to start a clip and I only want it to apply to a certain number of commands. So I can do that with the scope environment. We can also use scope to apply a group of options to a large number of things. Now, I could have done this with that every node style that I was showing you before, but maybe I had some nodes later on that I didn't want their font to be of size script size, or I wanted their anchor to be in another location. So this would be a way that you can essentially control which nodes get access to. So summary, there's a very useful language for specifying vector graphics. Specifying graphics in this way gives you the ability to provide exactness that can be hard to do in Xfig, not impossible, or other drawing tools, but can be a little bit harder. You've got the familiar graphics concepts, points, lines, and so on. Meshes well with PDF tech. Reasonably comfortable learning curve, and so on, but definitely a learning curve. Definitely like to thank Tiltantau for developing TikZ, and haven't left much time. Any time for any questions?
If there is a self-intersection path they want to fill, will it discover there is a problem?
If there's a it uses what is it? Odd even windings. So it won't discover it. It will it has the potential. It'll fill it incorrectly depending on how the intersections are.
I have 2 questions. First question: is it possible in TikZ to find an intersection of 2 paths
Yes.
and put their name and use it as a point?
Yeah, there is a path operation called intersection that allows you to do just that.
And second, about working with PDF LaTeX. When I put something in a node, some piece of text, is it possible for there to put, for example, href command for hyperref, and so make a part of your picture clickable? So I have a picture, I click exactly there, and I have it.
I don't know.
So, okay.
I love that. That's a great idea, but yeah, I'm not sure.
What exactly could you put in the text box as a label or something on your picture? So what are the limitations?
Just an H box or something, right?
Yeah.
So anything.
I think anything goes.
Yeah.
So this should work.
I think it'll work, but I don't know for.
Okay.
I don't know for sure.
Thank you.